Today in class, we learned about the Pythagorean theorem and basically how we can prove that a squared plus b squared actually in fact equals c squared. So for homework tonight, I wanted to show you another way to prove that a squared plus b squared in fact does equal c squared. So for number one, it says, how do the areas of the two smaller squares compare to each other? So I actually cut out all of the squares. So I have my pieces here. I have my right triangle right here. And then I have my squares already all cut up, basically. If I piece it together again, you'll see that it is in fact a square. And the questions is asking, oops, goes this way. The questions is asking, looking at the two squares, what do we notice? So if I put them actually back together again, you're going to notice that they should be exactly the same, considering they're 5 units in width and in length. So I have two of these squares that are exactly the same. So when they ask you how do the areas of the two smaller squares compare to each other, compared to each other, they're exactly the same. The areas are equal because they are 5 units in length. So that tells me that each square has the area of 25 square units, because 5 times 5 is 25. Then for number 2, it says, do all 8 triangles fit inside the square drawn along the hypotenuse? And remember, today in class, we learned about the right triangle. These two are the legs of the right triangle because we have a 90 degree right here. So that's 90 degrees. Across from the 90 degrees is what we call our hypotenuse. It's the longest side of the triangle. So the question's asking, do 8 all squares fit inside the square drawn along the hypotenuse? This is the square that was drawn along. So they want to know, do these little triangles fit inside of the large triangle? So I want you to go ahead and place them and see what your answer is going to be. Do these 8 triangles fit into this square? For number 3, it says, if all 8 triangles fit exactly inside the largest square, what does this imply about the sum of the areas of the 8 small triangles and the area of the largest square? So if this is the area of the largest square, and we look at all 8 triangles, and we're saying that these all fit inside of this, what can we decide about the area of these 2 squares and this one big square? Well, for me, it seems like if all of these fit into here, then both of these areas must be equal to each other. So for number 4, it says, what is the area of one small square? Well, we figured that out for number 1. We talked about how it was a length of 5 by another 5, so that gives me 25 square units. Then it says, what is the sum of the areas of both small squares? Well, if one is 25 and the other one is 25, then I end up with 50 square units. So now they're asking, what is the area of the large square? Well, if all the small pieces fit into the large one, and we decided in number 3 that they're equal, then the large square must also equal 50 square units. So how can we decide what is the length of each side of the square? And when they ask that, they're asking about the big square. How do we know what the length of this is? Well, just like yesterday's homework, we discovered that if we square root the area, we should be able to find the side length. So if I square root 50, that will eventually get me the length of my square.